Okay, today I will show you how to plot your microarray data. We will go first through the very basics of how to get the data to plot. And then I will show you how to do these volcano plots and the expression plot. So let's dive into it. The first thing that we want to do is to load the libraries. And for the plotting, we will be using this ggplot2. So we go ahead, we load those libraries. And the first thing that we'll need to do is to upload the data. Here we are going to use the most simple example where we have two conditions that we want to compare, one control and one experimental. So we launch that, we load the phenotypic data, and we also created the expression set. So the phenotypic data is stored in this pdata file. And again, we have 4 control samples and 3 experimental samples. We obtain at the end of the day this expression set, that this is the values for the intensity of the probes for each of these conditions. So we have, like, for this first probe, the intensity values for the 4 control conditions and the 3 experimental conditions. So this is nothing new. By the way, all the code will be down in the description if you want to look at that. And also we have videos dedicated to this part. But I just want to introduce the example that we are using. The other thing that we are going to do is load the annotation, and we'll do it by using this file here that we downloaded from the internet. Also, again, go to the basic video if you want to understand more in detail what is going on here. But at the end of the day, we have this annotation file where we just have for each probe ID, the gene name, a little description, and also what type of RNA is this. So then we move ahead to the contrast. So we want to have a design where we compare the control with the experimental samples, and then we want to fit the model. So if we look at the design, is as simple as it can be. We are comparing the 4 control samples with the 3 experimentals, and then we feed that model to our expression matrix. Now, the last step, we want to get the statistics. So we do this second fit here, and we are going to use this contrast where we compare the control with the experimental. And then we will create all stat tables that contains also the annotation, so that we have everything in one table. And in addition, we are going to highlight or to indicate what genes have a log-fold change more than 1 and have a significant adjusted p-value that we are going to consider above 0.05. So we run that, and we end up with this all stats data frame. If we look at that all stat data frame, we have the probes, the annotations, and also we have the statistics for every probe, and this additional column where we have those probes or genes that have a significant adjusted p-value and also have a log-fold change of more than 1 or less than -1. What we want to do here first is to plot this data, and probably the most common way of plotting expression changes is using the Volcano plots. In these plots, we have in the y-axis the adjusted p-value, and in the x-axis we have the log-fold change. We are going to use data, therefore, that is already included in that all stat table. So the plotting here is quite straightforward. We are going to use ggplot2, and this is the syntax of this library, which is very intuitive. We are going to call x the log-fold change and y minus the log10 of the adjusted p-value. We are going to use this geonPoint to plot just the point, and we are going to do some very minimal annotation that I'll invite you to expand. But essentially, when we run this, we have our volcano plot, again log-fold change x-axis, and in the y-axis we have the adjusted p-value, and also we colored those that are adjusted p-value bigger than 0.05 and log-fold change bigger than 1. So far so good. The only thing that this volcano plot lacks is the intensity of the probe, and although there is not a direct correlation of expression and intensity of the probe, is a good proxy to understand how abundantly expressed that transcript is. So what we have to do is to go back to the expression matrix and integrate that data for each probe. Essentially, this is what we are doing with this bit of code here, which I will not go into details, but essentially what this does is to create this plot table, which has, again, the probe set ID. We just are keeping here the gene name as annotation. They have the log-fold change value and the adjusted p-value from the all stat data frame, and it has the expression or mean expression for the control and the experimental samples. And with that, we can plot the mean intensity of control, again, experimental, and we use it again doing the ggplot. This is again very intuitive. We have the control, again, the experimental, we have the same type of geometry, and what we end up is with a plot where we have the significant points highlighted here in blue, and those probes that have genes that are not significantly changing are marked in red. So this is the second type of plot. It incorporates now expression data. It's complementary to the Volcano plot because you can sort of infer the fold change. With that, we conclude probably all what you need to do for microarray analysis. We cover the basic, we cover how to do quality control, we cover how to do multiple comparison, batch effects, and now we have covered the plotting of this data. For probably the final chapter of these microarrays, I want to use AI tools to do this analysis. So in the next video, we will have how to do all of this with GitHub Copilot, so that you can sort of forget a little bit, but if you remember the basic, you may be able to get the details from Copilot. So don't forget to watch this video, and I will see you next time.